In this lesson, we're going to talk about how to factor trinomials. So we've already talked about the factoring technique using the GCF, where you determine if there's a GCF within the polynomial, and then you pull that GCF out of the polynomial. So that was the first factoring technique that we've learned. So now we're going to talk about specifically working with trinomials and what that looks like. So let's first go ahead and take a look at this little formula up here at the top. So this right here is your standard form of a quadratic equation. So you can see that we have a coefficient of a in front of our x squared term, and then we have a coefficient in front of the in front of the x, which is called b, and then we have a constant c. What we're going to be focusing on today is factoring trinomials when the a coefficient is equal to 1. So we're going to take a look at examples at that, and then in the next lesson we'll talk about looking at that a being a number that's greater than 1, so something like 2 or 3 or 4. Okay, here's how you factor a trinomial. So the first thing I personally like to do is look at it and ask myself, can I pull out a GCF from this trinomial? And obviously for this first one, we cannot pull out a GCF. So I'm going to use this factoring technique. Now I like to use this little technique that I'm about to show you, but once you start getting used to this, you don't actually need to write down the factors of and the sum of. So here's how you do the first one. So here's our polynomial, and we want to figure out two numbers that are going to multiply to give you 12. So I'm looking for the factors of 12. That's this third term here. And then I'm looking for two numbers that that add to give you 7. Okay, so that's my goal. I want to find the factors that multiply to give me 12, and that those same two numbers will add to give me 7, that middle number. So you might be starting to generate some thoughts in your head, and you might think, well, 4 times 3 will give me 12, and 4 plus 3 will give me 7. So those are the numbers that we're going to use. Okay, once you find those numbers, we're going to go down here, and whenever you factor a trinomial, it's always going to create two binomials. And the binomials are always going to begin with an x and an x. That's how you get that x squared term up front. Now we're going to go ahead and place those factors into our binomials. So I'm going to say positive 4, and I'm going to say positive 3. And that's it. You've factored your trinomial. I got my positive 4 and my positive 3 from my factors and my sum. So that 4 and that 3, that's where I got those terms. So this one was unique because this one had an addition sign and then another addition sign. So we're going to look at a couple more that have some differences. So let's go ahead and look at one that has a subtraction and a plus, so the one right below it. So I'm looking at this polynomial here, I'm looking for factors that will make 50, and I'm looking for numbers that will give me the sum of negative 15. So you want to grab that operation in the front of it. So if you start generating some ideas here, you might think, well, negative 10 times negative 5, that will give me 50, right? And if I take those same numbers, negative 10, and I add negative 5 to it, that will give me negative 15. So I've found my two numbers. So I'm going to go down and I'm going to create my two binomials. I'm going to start my binomials with my x. That's going to give me my x squared. And then I'm going to simply fit my factors in. So negative 10 and negative 5. And a great thing about these types of this type of factoring is to check yourself, all you have to do is use the FOIL method. So if you use the FOIL method, you should end up getting the original problem that you started with. And if not, that means that something went wrong. Okay, let's try another one. Okay, up at the top, we are looking for factors that when multiplied will give you negative 20, and we're looking for numbers that will give us negative 8. So you could think about this one, but don't think for too long, because we're going to end up just having negative 10 times 2. Okay, so negative 10 times 2 will give me negative 20. And then we have negative 10 plus 2. Well, that will give me that negative 8. So perfect. Didn't take too long to get that. So I'm going to go ahead and create my two binomials. I'm going to drop my x's in there. And then I'm going to go drop my numbers in there. Negative 10 and positive 2. And there you have it. You've factored your trinomial. All right, let's do one more. Okay, so for this one, we're looking for factors of negative 45. So two numbers that multiply to give us negative 45. And then two numbers that add to give us positive 4. Okay, so if we think about this one, I'm thinking about 9 and negative 5 personally. 9 times negative 5, and then 9 plus negative 5. Okay, so I'm going to go ahead and create my two binomials at the bottom. I'm going to start them with my x, and then I'm going to pop my numbers in. I have a positive 9, and I have a negative 5. And there we have it. We have factored the trinomial. So now, basically what this means is that when you're asked to find the factors of the polynomial, those two things that we solved for, those two binomials, those are called factors. So now we have our two factors of the trinomial. All right, let's try two more. And these ones are kind of unique in a way. So let's look at the first one here. I'm looking for numbers that multiply to give me negative 32 and that are going to add up to give me negative 8. Okay, for this one, you might struggle trying to find two numbers that multiply to negative 32 and add to negative 8 because there aren't any, unfortunately. So if you can't find any factors that will multiply or add up to those numbers, then this is actually an unfactorable problem. And what we like to do is we like to call these prime trinomials. And basically, that just means that you can't factor them. They are fully factored, and that answer that you started with is actually, it's fully factored for. Okay, we have another unique one here. This one has two variables. So it doesn't just have the x and the x squared. It actually has x squared, xy with a y squared. So treat these kind exactly the same as the others. So we're still trying to figure out our factors that multiply to give us positive 18, that last number, and that add up to give us positive 9, that middle number. So don't get mixed up with all the variables. It's just treat it the same way. So when I look at these and I kind of think about these, I'm thinking about 6 and 3. So 6 times 3 will give me 18, and then 6 plus 3 will give me 9. So what I'm going to do is I'm going to go down and I'm going to create my binomial. Now, the only thing that is different here is this. I'm going to start with an x and an x, just like normal, but I'm also going to drop a y and a y in there, because that's how I'm going to get my y and my y squared. Now, I'm going to go ahead and do exactly what I did before. I'm going to say plus 6, which is one of my factor numbers, and then I'm going to say plus 3, which is one of my other factor numbers. And there you have it. You have factored the trinomial with two variables. Okay, so at this point, we're going to go ahead and stop there. And this was just a quick lesson on factoring trinomials with a coefficient of 1.